Hello guys, hope you guys are having a good day. My name is Brian Estoso. I'm doing this for my CSCI 3329 Summer 1 course. We're going to be going over the S.O.L.I.D principles in OOP and Python. So we're just going to go over some slides, and after each principle I'll be just going over some code samples. I'm going to be going over the good example, and I'm going to be going over the bad example as well, just so we have like a clear idea. And of course the code will be like simpler than what the actual implementations could be and could lead to. It's just a rough sketch of things, and it's just so you can visualize what the principles are. So let's go ahead and go to the first slide. So the first slide, in the S.O.L.I.D principle, S is a single responsibility principle. So on single responsibility principle, it just means that your class should have one responsibility. That's the formal way of writing code, and given your class more than one responsibility, whenever you're going to change it, you're going to encounter various issues. You may have bugs, and it's a unclean code, and it's a not a good way of writing code. Your code should only have one reason to change. Single responsibility does not mean that it can do one thing. It just means that whatever is in that class should be closely related. So it just doesn't mean that every time you're gonna do something, you're gonna write a class for that. It just means that whatever is in there has to be really tight together. Otherwise, you can write it in a different class. So just bear in mind. And let me go ahead and show you the code sample. Alright guys, so we're going to get started with the code implementation. So we're going to do just a good sample of how the single responsibility principle can be used. So in this example, I'm just going to create a parent class called employee, and then some subclasses that inherit from employee. So it's just, we're going to do a sign up login kind of like system. So for that, I'm just going to create an employee list. This is going to be just a global list where we can store like the attributes. So let's go ahead and create the employee class, and for that one we're gonna have the name and ID attributes, and just that'll be it. And then for the class, we're gonna do sign up, and we're gonna store inherit employee parent class. And then for that one, we don't really need to do much. We're just gonna do self name and ID. So here we're just gonna do super. We're gonna inherit the name and ID from parent, and then from there we're gonna create a nested list. It's we'll be storing the self name and self ID. There we go. We're gonna append this guy. So append employee, and we're gonna create a class login. Same thing, we're gonna implement the rest. We're gonna do the for loop for L in employee list, and if let's see, for if we're gonna do self dot name equals L one, and self dot ID equals L. And outside the for loop, if we went through the whole list and we couldn't find it, we're gonna just do employee not found. So on this guy, we're just gonna implement it. So employee one. So that's it, and let's go and run it. See what shows up. Yep, there we go. So here's something went wrong. Let's see. So since we have a for loop, if we don't add a return, it's gonna print this last statement. So we'll just add a return, and there you go. So there we go. So it did find that those credentials, the attributes there on the list. And this is just a good way of implementing the single responsibility. So this class has the responsibility of logging in, and this class sign up is just focuses on signing up with attributes, creating a nested list that is added to the global list, and employee is just it just works for adding the attributes. And that's pretty much it. So let's go ahead and try the bad example now. So for the bad example, it's pretty straightforward. Let me just comment this. For bad example, we can just same thing. Oh, we'll just keep the employee list right there, and we'll just create a class called employee, and then self name, ID, self name, ID. The only thing here is that we're gonna create the functions sign up. There we go. And same thing for the login. For the login, we'll just do for L and employee list. And let's go and implement it. So employee one. Again, it really doesn't make a difference here because it's a small piece of code. But if you're gonna actually implement this on something bigger, if you're working on a big project, on a group project, it's better to separate classes according to task, not put everything together. Even though they can be like remotely related, it's better to just keep whatever is needed in one class and just keep splitting the task into separate pieces of work, which you can later on modify. And whenever you're gonna modify it, you're not gonna mess with a big chunk of code. You're just gonna mess with a smaller portion. So there you have it. That's just the single responsibility principle. So let's go ahead and go to the next slide. All right, guys. So for the next slide, it's gonna be the open close principle, the O in S.O.L.I.D. So this principle just states that a piece of code should be able to add functionality to the code without changing the current existing code. So this is just open for extension and closed for modification. This just means that you want to protect whatever code you've previously built before. You don't want to drastically change it. You just want to extend and build upon it. So one of the most common examples in OOP and Python. So whenever you're performing inheritance and polymorphism, usually you want to add an abstract method, build an abstract class if you want to build something that follows the open close principle in the exemplar way. So let me go and show you that in code perspective. Alright, guys, so we're gonna go ahead and get started with the open close principle. So good example, open close principle. So what we're gonna do here, we're gonna import from ABC, import ABC. That way we can utilize abstract methods and build an abstract class. So we're gonna build a class employee, and we're gonna initialize it with the same attributes that we've done before. And this will be our abstract method. It's gonna be dev calculate bonus self, and we can build another class called developer that inherits from employee. And in this one, we're gonna do the dev calculate bonus. We're gonna do this. We're gonna do, in this case, we're just gonna return salary times salary times 0.05. That'll be the bonus for the developer, and we'll do the manager. So there we go. So we can do employee 1 equals developer Brian. Let's go and see. So here, Brian, your bonus is 75. So why? Let's see. Oh, because I put like I get a million. So that's the bonus. So this is just a good way of implementing the open close principle. So with abstract methods, you can create a method that you have to implement on the subclasses. That way you can only expand on it. You cannot just create something different. If you're gonna do this piece of code that inherits from the parent class, you cannot drastically modify the code. And let's go and do the bad example. We're not gonna use abstract, so we're just gonna do class employee, and yeah, just initialize it. Self name ID. So we're gonna change the attribute to position, so that way we don't have to type a lot on the code implementation. So we're gonna do if self position is equal to manager, return self salary times 0.05, else this, so this, we're gonna put this. Oh, is it that? So salary. There we go. And now we can actually create employee1 equal calculate bonus, and we should expect a print message. Let's just go ahead and comment this. Let's see. There we go. Your bonus is 20,000. So this is just a way of showing you that if you're gonna expand upon it, you're gonna have to modify the actual class, the parent class. This is not a good way of implementing your code, because you're gonna encounter various bugs. So the best way to do it is just separating this task into multiple subclasses. If you're gonna expand it, and you know that you're gonna expand upon it, or your team is gonna expand upon it, it is better to just create subclasses with abstract methods. That way, you're really not changing the purpose of your code; you're just expanding upon it. So it's open for expansion, closed for modification. So there you have it. So let's go ahead and go to the next principle. All right, and for the next principle, in L is the Liskov substitution principle. So this one just states that objects in the superclass should be replaceable with objects in its subclasses without breaking the application. So this is just this principle states that the subclasses must honor the contract that they have with their parent class. If a subclass does not naturally fit in with the superclass, the parent class code, don't force inheritance on it. This could be shown with abstract methods. If you have to implement that method to that class, and that class does not handle the method the way it should be, or the way the other subclasses and the parent class handle it, it shouldn't be coexistent in that same environment. So you cannot force that subclass by just throwing an exception or just making it crash. It's better to just separate it into its own group. So let me go ahead and show you that in a code form. So let's go ahead and go to code. All right, guys. So let's go ahead and do this. Let's go ahead and do the good example of the Liskov substitution principle. So on this one, we're also gonna do importing. So from ABC, import ABC abstract method, and we're also gonna be implementing the class employee. So we're gonna utilize that abstract method, and we're gonna just initialize it, name and ID. Alright, and our abstract method, there we go. So we're gonna just pass, and this is what's gonna be implemented to its subclasses. So for example, we're gonna make a subclass manager, and we're gonna just return salary, and class developer employee return salary times 0.05. And we're also gonna do, so this is gonna be a bad example right here. So bad example is making a subclass. For example, we're gonna make a subclass called intern, and we're gonna force. Well, it has to utilize this method since it's abstract. But in this case, we're gonna raise exception, and interns do not get yearly bonus. So that's gonna be your exception. That's gonna raise a flag. So we can build a function that utilizes the classes, and we're gonna be using employee. We're gonna use the class here. So here we're gonna do bonus equals employee dot calculate bonus, and we're gonna print employee dot name. Your yearly bonus is, and so we're gonna do bonus right here. So right here we can do print. We're gonna do print bonus, and we're gonna use, let's just do the manager class. So in the manager class we did the name and ID, so we're just gonna call Brian, we're gonna do Joe, and let's just clear that out. Let's see, enter your yearly salary. Brian, your yearly bonus is 20,000. Enter your yearly salary. Joe, your yearly bonus. So, and now let's try to implement the intern subclass here. Intern. Let's call it Mike. Mike 345. And you're gonna see how we did build a exception. So it is gonna be flagged. So right here, raise exception. Interns do not get yearly bonuses, but this is forcing this this subclass. This shouldn't be forced in. You should just use the subclasses or implement the subclasses that are able to use the abstract methods to their full potential. The subclasses should be able to do whatever the superclass does, or at least what it wants to do. This one does not do that. So yeah, so intern can be something else. It can be like a volunteer class. For example, is this employee class? We can do a volunteer class, and that's for interns, or something else. But you shouldn't force a subclass into a class that's trying to do something. So yeah, so let's go ahead and go to the next slide. All right, so for our next principle, it's going to be the interface segregation principle. So this principle just states that you shouldn't make your code, for example, classes, implement methods that do not make sense for them. So it is essential to segregate code into like smaller and more specific interfaces, rather than just implementing the code. And like the previous principle, don't try to make it feel forced. Just try to segregate whatever makes sense together. For example, let's just say you have a parent class with two abstract methods, and you want to create subclasses that only take one abstract method. Uh, you shouldn't implement that sort of code. What you can do is create two abstract classes and designate one for that subclass that handles that abstract method, and then the other one with the other one. Just pair them like with each other, rather than just create one big parent class that has multiple abstract methods that your subclasses will only utilize some of them. So let me go and show you that in actual code. It's going to be a very concise, very simple example. So let's go and continue with that. All right, guys. So let me go and show you a good example of the interface segregation principle. So with that, we're gonna use abstract methods. Import ABC abstract method. So we're gonna create a worker class. So worker that inherits ABC code, and we're gonna create another abstract class that's it's gonna be leader. So same thing here. So abstract method. So here is where we kind of separate the subclasses into their individual abstract parent class. So for example, worker, we can do a class developer that inherits worker, and this is where we do the code. Very simple text that we're gonna implement here. And then for the leader, we're gonna make a subclass called manager, and it's gonna inherit the leader abstract class and manage. So now that we have that, we can create an employee one, and we can call in the code method, and same thing for employee 2, and we should be able to see those the text here. Yeah, writing code. So this is coming from the employee object. So this is using the developer subclass, which inherits the worker and its abstract method. Same thing for manager, which inherits the leader parent class with its abstract method. So this is just a way of showing you that the interface has to be segregated in order to create just a better system of code. So for example, let's forget about all this. Let's just do from ABC import. Let's create a bad example. So here we're gonna create a class called employee, which inherits the ABC, and here we're gonna do the abstract method. And now the subclasses, for example, class developer, which inherits from employee, has to utilize those codes. So for example, code. This is perfect for it because it's the same thing, writing code, but it also has to use manage, which, let's just say that a developer is not a manager, so developer is not a manager. And same thing for the manager subclass. So we can implement this into your object. So let's just say employee 1. So in some sense, you're just writing extra code. In the long term or in the bigger picture, it's gonna affect you more than what this example is showing. But you're forcing or you're including things into your code that shouldn't be implemented. For example, the abstract methods, since you're just going in, gaining everything from one place, one interface. In this example, is this abstract class. All the subclasses have to include it. That is why it's important to segregate the interface, segregate the abstract classes. So let's just run it real quick. And there we go. So writing code, developer is not a manager does not code, the leader is leading the team to victory. So this is just showing you this is just a bad way to do it. Implementing abstract methods into subclasses that don't need those abstract methods. It is better to just create 2 abstract classes and segregate its subclasses into what they actually work for or what their purpose is. So yeah, so this is just a simple way of putting it. So let's go ahead and go to the next slide. All right, so for the last principle, which is honestly the one that I've been having kind of a rough time understanding, it's the dependency inversion principle. So this one just states the software. Your software should be open for extension but closed for modification. Kind of like the way your code, classes, and methods should work. But this is more into like a high level module with low level module kind of like interaction. So both should depend on abstractions. Since you want to have it open for extension, you don't know what type of software you want to use next, or if you're going to use multiple softwares. For example, there's databases, there's loggers, there's APIs. In this example, we're going to use loggers, but I saw an example of databases. There's MySQL, and then there's the other software for SQL. I forgot the name right now, but high level modules should be your core logic, your classes, your methods, whatever you're implementing, and low level modules, like I said, is your tools. So your high level modules, your code should not be dependent on a concrete low level module. They should be implemented with abstractions. That way, whenever you change or add a low level module, add another software, another database, another logger, you don't have to modify your high level module. You don't have to mess with it anymore since it's open for extension, which is the best way to write code in. So I wrote a simple logger code. I'm new to logger code, so let me show you what I have. So let's go and go to the code. So I'll try to be quick with this example. So in this one, we're gonna show you the good example of dependency inversion principle. So in this example, we're gonna also use abstraction typing. So in here, we're gonna make a parent class called a logger interface, which is gonna take in abstraction, and it's gonna have its abstract method. And now we're gonna make the subclasses. So for example, we're gonna do a console logger. Here we're just gonna print, and for the next subclass we're gonna use file logger, which is gonna take the logger interface as well. You have to implement the abstract method. So in this one, we're gonna open a file. We're gonna basically create a file. It's gonna be called employee log.txt, and here we're gonna just append some text, and we're gonna add a line as well after each message. So this is gonna be our low level module. So low level module, this is pretty much the software that we're gonna be using. And then we're gonna do the high level module, which is just a regular code, which is like class employee, and here we're gonna make another class. It's gonna be called bonus service. I think it's bonus service. And so this implements abstraction. So whenever you implement the code for implementation, you can basically use this class and its method to implement any type of software that we want. So we're gonna do another function. So here we're just calling whatever we have here, whatever we implement, we're gonna use its method with its function. So it could be either or. It could be this guy right here, the file logger, which creates a file and adds whatever message we have into that file, or we can just do the console, which just prints from our console. So now that we have all that, we can actually implement it. So let's just create a logger variable, and we're gonna use the console logger. So here we have an implementation. So this is the console, and let's use another one, which is the file logger. So for file logger, it's pretty much the same thing. Employee 2. So here we can. So we still printed the console message, but if we look at our files, we created a text file that has the Joe, you receive a bonus, the message, and it added a new line. So we were able to implement both by just changing this bit of code. Everything else is the same. It's just the changes. So that's the good thing about this this sort of system, dependency inversion. That way you can utilize abstraction to its best. So let's go and do a bad example now. This is going to be our main parent class without any abstraction, and then we're going to make a class employee, an employee class, which also just doesn't inherit anything. And we implement the same class bonus service. We initialize it, but instead of using an abstract class, we're going to be using the only parent class for console that we have, which is the console logger. And now we create the other one, give bonus, and here we can just do the message now, which is going to be console message. So employee name. So right here with the self logger, you're just calling in this guy right here, which just prints out this, and the message, which is this guy right here. It's just this. So now that we can call it, oh, we just have to implement it, of course. So this should be able to utilize our bonus service object, which is from this class right here, and we can use this method, the give bonus right here, which intakes the employee class, which we just created an object for. And bonus two were given, self-employee, the initializer, since we don't have bonus service object has an attribute salary. Just modify this. There we go. So we get the print console. Your bonus is 15,000. But like I said, since we don't have any abstraction, whenever we add another logger, for example, file logger, we're gonna have to modify this right here, our high-level module, and not so much this. It's just this right here, our bonus service, which is our kind of like our main code where we're gonna implement various calls. So yeah, that's gonna be a pretty concise example of dependency inversion. So let's go ahead and go back to the slides just so I can give you more or less like a vision on how it works. All right, so I did a slide just to like imagine. So just imagine that you have just a setup for your electronics. So a good way to set up all of your electronics is, of course, buying like a power switch or a power strips that connects all of your electronics in one spot. It's very easy to use, disconnect, connect. It really, your electronics shouldn't care where you're plugging them in. They'll just be easily swapped out, removed, or add new electronics at any time. That's how I can picture the dependency inversion principle. And a bad setup, a bad implementation, or just like avoiding the implementation is not having any strip to connect to. You just have your closest wall plug. So, for example, you have your computer and your screen connected, but if you want to charge your laptop, you're gonna have to look for the next wall connector. You have to disconnect or look for like further places to connect them. It's more of an arduous task, and it requires you to touch like your power supply or your actual electronic cable or whatever on every change, instead of having a power strip that you can easily connect and disconnect at any time. You're really not messing that much with the cabling or the electronics, since it's just connecting them into something that a power strip that connects to any sort of power. That's how I kind of picture it. I know it's kind of like a rough, blurry vision, but hopefully I will be able to learn more about this principle and all of the principles mentioned. So yeah, so this is just a little bit of what I've learned so far, some code that I've been working on, and it is good to have some sort of principles or some ways of doing code that are universal, uh, something that can be measured, um, to determine if you're a good developer, a good coder, if you understand the language, you understand its principles and the way it should be used. So yeah, this is it for the video. Thank you guys.